In this video we're going to go over standard form conversions. So standard form notation is used to represent very large or very small numbers. So if I do some examples, convert the following to standard form. So this is 150,000, which is a very large number. So to convert to standard form, we basically have three portions. So we have like a decimal times 10 to the power of, say, 7. So this is the usual standard form notation. This larger number is between 1 and 10. So not including 10, it'll be 1 to 9, sorry. And then times 10, which is usually a small 10 on the calculator. It's given by this button here, times 10 to the power, times 10 to the power of x. So 1.5 times 10 to the power of 7. So that kind of shows how you can write this really long number as a shortened version. So if we do that with these ones, you count how many times the decimal place moves. So you have a decimal place here because you've got 150,000. We go 1, 2, 3, 4, 5. So that shows what power of 10 it is. So this is equal to 1.5 times 10 to the 5. Because starting from here, so the very right, assuming it's above 1 and not a decimal, from the very right you move 1, 2, 3, 4, 5. And when the point is there, if a decimal point is between there, it's 1.5. So 1.5 times 10 to the 5. If we check on our calculator, 1.5 times 10 to the 5, it gives us 150,000. So if we continue with these examples, we have the decimal point here. So this is quite a small number. The decimal point moves 1, 2, 3, 4, 5, 6. 6.7. Remember, it's got to be between 1 and 9. So this is equivalent to 6.73 times 10. And the decimal place moved 1, 2, 3, 4, 5, 6 times. So it's to the power of negative 6. So if the decimal point moves to the left, it's positive power. If it moves to the right, it's negative power. If we do this example, we have 167,926. So depending on the number of significant figures, this could be rounded, but say we wanted the exact number, which is in very rare case, or you would just leave it as it is. This would be 1.67926 times 10. So we have a decimal place here. 1, 2, 3, 4, 5 times 10 to the power of 5. We do our next one. So it's equivalent to 2.5. 1, 2, 3 times 10. Because we're moving to the right, it's minus 3. We have 36,729. So 3.6729 times 10. We have a decimal point here. 1, 2, 3, 4 times 10 to the power of 4 because we're moving to the left. And this example equal 1 times 1, 2, 3, 4, 5. So this is 1 times 10 to the negative 5. So you see how this shortened standard form notation is a bit easier to write than these numbers. And these numbers aren't even that big or small. You can get much smaller and much bigger numbers. So if we do some converting from the other way, convert the following from standard form to decimal form. So we have 5 times 10 to the 4. So that's equivalent to 5. So imagine we have a decimal place there, and the decimal place moves 4 times. So 1, 2, 3, 4. So our value is 50,000 because the decimal place moved 4 times. If we do this one, 6.7 times 10 to the negative 3. So because we established earlier, when we're converting from decimal to standard form, the power is positive when you move to the left, and the power is negative when you move to the right. The complete opposite happens when you convert the other way. Kind of like how when you convert from centimeters to meters, you divide by 100. So from centimeters to meters, you divide by 100. Meters to centimeters, you multiply by 100. So you kind of do the opposite. So 5.4 times 10 to the negative 4. We start from after 5 and we move to the right to convert from standard form to decimal form. Well, for this one, we have 6.7 times 10 to the negative 3. So this one we move to the left. So 6.7, 1, 2, 3. So the decimal point ends there. We have 0 and 0. So the decimal form of this is 0.0067. We'll continue with this one. 2 times 10 to the 2. We move to the right. 1, 2. There. We have 200. For this example, 2.3 times 10 to the negative 5. So 2.3. 1, 2, 3, 4, 5. So 2.3 times 10 to the negative 5 is equivalent to 0.000023. For this one, 1 times 10 to the 6, to the power of 6. 1, 1, 2, 3, 4, 5, 6. So 2, 4, 6, yep. So 1 times 10 to the 6 is actually a million. Is equivalent to a million. 9.7 times 10 to the negative 1. 9.7 to the negative 1. Decimal point ends there. So 9.7 times 10 to the negative 1 is equivalent to 0.97. And that's how you convert from standard form to decimal form.